video, we are going to talk about the end behavior of a graph. So what you're going to do is you're going to use the leading term. The leading term of a function is the term that has the highest exponent. So in this, what I have written out here, 3x cubed plus 2x squared minus 3x plus 5, this is your leading term because it has the highest exponent. So what you're going to do is determine whether the exponent is even or odd. So the number 3 is odd, so I am going to have an odd. So that puts us on this chart over here. You'll notice that all of them in this first column are even. The second column is odd, so we are in the odd column. And then you look at the sign of the coefficient. So that's a positive 3. So this graph is going to have an odd positive end behavior, which is this one here. What that means is when you are looking at this graph, it's going to have an odd positive end behavior, which means going down on the left and then throughout the graph going up and ending up on the right. That is how it looks if you are odd positive. All right, here's another example. We've got negative pi x to the 6th plus x to the 5th minus x to the 4th minus x plus 7. So again, I'm looking for the term that has the highest exponent, which is this one because its exponent is a 6. So 6 is an even number. So in my chart, I'm coming to the even column. So this column here. And then I'm looking at the sign of the coefficient. So this one's sign is a negative, which means it's got an even negative end behavior. So on the graph, if you are even and negative, both ends of your graph are going to be pointing down. On this next example, I have negative 4x to the 4th plus x to the 6th minus 0.8x to the 7th. Remember that your leading term is not necessarily your first term. It's the term that has the highest exponent. So I'm actually looking at this term because 7 is the highest exponent. So 7 is odd. So I'm looking in the odd column. And the term is negative, which means it's going to have the odd negative end behavior. So we're looking at this one. So it's going to start up on the left and then travel down and end up down on the right. All right, on this next part, we're going to use substitution to determine if a number is a zero of a function. This question, I have f of x equals x to the 3rd minus 8x squared plus 13x plus 8. And I'm going to see if 3 is a 0. So the way that I'm going to do that is I'm going to replace the f of x with a 0. I'm going to replace all the x's in the function with 3's. So I'll have 3 cubed minus 8 times 3 squared plus 13 times 3 plus 8. And then I'm just going to put all of that in my calculator. So I'll put exactly what I had in the calculator. So I need to have open parentheses, 3 close, and I'll raise that to the 3rd power. minus 8, open parentheses, whoops, open parentheses 3, close, plus 13, open parentheses 3, close, plus 8. So that has replaced all the x's in the function with 3's. When I hit enter, I get a number that is not 0. So since I got a number that is not 0, then it is not a 0 of the function. To be a 0 of the function, you'd have to have 0 equals 0, and since we did not get a 0 in our calculator, then it is not a 0 of the function.